basics. I know that maybe you have learned a little bit of it, okay, in your physics, right? That is pertaining to your SI prefixes, okay, your tera, giga, mega, and all the way to mole or nano. Okay, so you will be happy to hear that unlike physics, in EMATS itself, okay, if you need to do this kind of conversion, the conversion will be given to you. Let's say the times 10 power what, okay, will be given to you. But of course, you are already remembering it in your physics. I don't think it should be a challenge. Okay. Now, before that, okay, we are going to know what exactly is standard form. I'm going to show you a set of numbers of what is considered standard form and what is not considered standard form. Okay? And then you tell me by observation what constitutes standard form. Okay, giving you this list over here from your observation. Can you tell me what are the features considered standard form? Yes, Okay, so Jovan says that the number over here. Okay, we see that some standard form something, right? It says this number over here is between 1 and 10. Okay, inclusive of 1 and 10. Okay. Inclusive of 1 and 10 also. Okay. Not inclusive. Okay, so this is what he observes. Any other observation? Okay, must be 10 to the power of something. Just going to use a star to indicate the power. What other features are there? Even if this number is between 1 to 10, okay, including 1. Yes, MX. The power must be an integer, okay, good observation. Okay, we see in the very last one over here, whereby this one does not qualify to be a standard form, okay, because the power is actually not an integer. Anything else? Okay, maybe first we understand this thing from Jovan. Between 1 inclusive and 10, it means that, okay, it can be numbers like 1, okay, it can be numbers like maybe 1.2, right? It can be 1.567, maybe not 1 again, okay, 3.567, okay, but it cannot be 0, right? Neither can it be 0.234, okay, and it also cannot be 10. So this is what Jovan is trying to tell us about between 1 and 10, including 1 but not including 10. Okay? Anything else? Nothing? Okay? So I think yes, we have kind of captured, okay, the ideas of standard form. There is standard form itself over here, okay. The number, the digit before the decimal place must always be one digit only, and that digit itself cannot be 0, okay, because we cannot have 0.206 as standard form. Okay, it must be 2.06 instead. Okay, that constitutes standard form. Okay, so we need to be clear about what constitutes standard form before knowing how to convert a number into standard form. Okay, and what is the purpose of us doing standard form? Because in science itself, okay, there are numbers that are very, very, very large or very, very, very small. Okay, for example, the distance from here all the way to the moon, or the distance from here all the way to the sun. Okay, these are all very large numbers. Okay, and we have certain units for it. Okay, therefore we want to actually express these very large numbers in a neat manner. That's why we introduce standard form. Okay. The opposite of standard form will be ordinary form. Ordinary form will mean that it is the entire number itself. So for example, okay, let's say the distance between the Earth and the Sun. Okay, not our Earth in this class, right? We're talking about 496,000,000 kilometers. Okay, it is quite a number of digits that we have to write. Okay, so this is what we call the ordinary form. And the standard form would actually be 1.496 times 10 to the power of 8. Okay, so we won't be learning how to convert numbers from ordinary form to standard form or from standard form to ordinary form. Okay, so don't worry about that. Okay, you may find that this number still seems manageable for us to write it out in ordinary form, but okay, what if you want to consider the mass of an oxygen atom? Okay, you will lose track of the number of zeros. Right, total it all. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. 0, 2, 6, 5, 6 kilograms. Okay, this is the mass of oxygen atom in your SI unit of kilogram. Okay, so this is our ordinary form, and if I want to write it in standard form, it will be much easier. It will just be 2.656 times 10 to the power of negative 26. Okay, so that is your ordinary form and your standard form. Right? I think there are 8 sets of triple zeros. 3, 4, 5, 6, 7, 8. Yeah.
That's great.
Okay. So let's learn how to do the conversion. Okay, let's start with a whole number. We have 5,300,000. Okay? Our agreement regarding standard form is that the number on the left of the multiplication sign must be a number between 1 and 10. Okay, so what I usually do is that I look for the digit that is non-zero, the first non-zero digit first, and that is 5. Okay? And then after that digit, I will decide that my placement of the decimal point will have to be here. Okay? So I'm not just going to directly plot it there. Okay? So I will put 5.3. I need not consider the rest of the zeros anymore. Okay, my decimal place has to be here. Then I times 10, okay, to the power of something. Right? This is where my decimal place is to be, but in the original number itself, the decimal place is actually here because it's supposed to be 5,300,000.0. Okay? From where I decide to have it to where it is supposed to be, okay, I'm moving the decimal point, okay, over to its original position, right, by 6 placing. Okay, and we have learned before in primary school that if I times 10 once, it helps to move the decimal point to the right once. Okay, so from where I want it to where it originally is, okay, I need to move 6 places, so therefore it is times 10 to the power of 6. Okay, because I'm moving it to the right. Okay, so this is where it originally is. Okay, and then over here is where I need it to be. Right? Let's try one more. 600 million over here. I need my decimal place to be here. But the original position is actually over here at the end of the whole number. I see that from where I need it to be, where it originally is, I need to move 1, 2, 3, 4, 5, 6, 7, 8. 8 places to the right. And therefore, I will have 6 times 10 to the power of 8. Okay, I need not put 6.0, you can just put 6. Okay, let's look at a decimal now. Okay, this is where it originally is. Okay, but where I need it to be is from the first non-zero digit, okay, after it. So I need it to be here. Right? So I need my answer to actually be 4.8 times 10 to the power of something. Okay, but in this case, instead of moving to the right, I'm moving to the left. And to move to the left, you understand in primary school that I need to divide by 10. And a division of 10 is actually times 10 to the power of negative 1. Okay, because we learned in indices that divide by 10 is the same as times 1 over 10. And 1 over 10 is none other than times 10 to the power of negative 1. So therefore, okay, in this case, from where I need it to be to where it originally is, because I'm moving to the right by 1, 2, 3, 4, 5 places to the left, it will mean that it is times 10 to the power of negative 5. Okay? This really needs you to be sure about what is considered equal. Okay, these two numbers are considered equal. Okay, so you must ensure that the value remains the same. So in part D, where should my decimal place be? Let's get someone. Teacher, can you tell me where do you think the decimal place should be? 1.67. Okay, 1.67. So we need it to be here. Okay, and where it originally is actually here. Okay, and therefore we see that our decimal place is to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. So I'm looking at 1.67 times 10 to the power of, sorry, I lost count, negative 10. Okay? Right? Clear about the conversion? Okay, from standard form to ordinary form. So I hope that with that idea, you understand how is it that the distance between Earth and the Sun, okay, could be actually converted from ordinary form this way to standard form in this manner. Because where I need my decimal place is here, where it originally is here. Therefore, I'm moving 8 places to the right. Likewise for this, I'm moving 26 places to the left. Okay, to ensure that they are equal. Right? Now, what if I have a standard form number and I want to change it into a ordinary form number or ordinary notation number? Okay? Put inside your calculator. Right? Sometimes you put inside your calculator, it can work, but sometimes it wouldn't. It will give you back the same thing. Okay? Maybe times 10 to the power 6, I think your calculator may be able to show you. Okay? But it's not all the time. You can try it. Okay? Let's try. I brought 3 different models of calculator today, in fact.
Wow.
Because later on we're doing a calculator exercise. Oh wait, my third one. Yeah. Okay. So just wondering anyone using this one, the sharp one. Okay. Just now I was just checking, right? I think this model itself, it doesn't give you many digits. Okay, so you do lose some digits when you calculate. Okay, but that's the problem later on we address. Okay. I think the Casio one shouldn't be a problem. Okay. So can you try? What do you get in your calculator if you put this in? What do you manage to get? You get the full number? Yes? Oh, you don't get it? Okay. So it really depends on calculator models. But of course this one is a simple thing. We know that times 10 to the power 6 means that from where the decimal place is, we are moving the decimal place to the right 6 times. Hence we are looking at the number 1,325,000. Okay. And if you look at part B, 4.4 times 10 to the power negative 3. I believe your calculator should be able to give you this number as well. But it isn't difficult. Okay, to know that we are moving your decimal place to the left by 3 places, so it should be 0.0044. Okay? Because from here it has moved 3 places to the left. Question? Okay, so your SI prefixes, no questions, huh? Okay, we move on to our SI prefixes. You can find them in textbook page 80. But as I mentioned, not necessary for us to remember it. But since you're all physics students, you would have remembered it already. By the way, I just want to ask, right, how do you write a micro symbol? Huh?
It's a mu.
Like that, huh? Right? Okay. I mean, just making sure that we all write it the same way, huh? Like that, huh? Okay, that we write it. It's a little bit of calligraphy. Okay, just want to make sure that we all write it correctly. Okay. You don't want to end up writing it such that it doesn't look like the micro. Like that also can now. Straight line, just like I think usually people don't write straight. Even in printing, it's slightly always printed. No, it's printed like that. Okay. As long as it looks like what it is, Practice now 16. I won't write the full question. Okay, this is just an approximation. I think our computing students in class, you will know that I think it's 1024 bytes, right, for 1 kilobyte. Not 1000, right? Oh, you're doing 1000. I think in reality it's 1000, right?
What do you say again, sir?
Huh?
What do you say?
I think 1 kilobyte is 1024 bytes.
No, that's TB.
Is it TB, huh?
Yeah.
Oh, okay, so I forgot already. But I remember there is an approximation that we're doing here. Okay, given for M. Okay, so part A, anyway, regardless of that, we're not going to use that, okay? So it says that this hard drive, okay, has a capacity of 4.0 terabytes, and we want to express it into bytes. Okay, so 1 terabyte is times 10 to the power 12. So to do the conversion, we just times 10 to the power 12, okay, and we'll get it in bytes already. Make sure you spell the bytes correctly, don't be ITES. Question 1 said to be in standard form, so we just leave it this way. Yes, meters. We want to convert this into meters. Okay, so therefore, you have 25.4 micrometers being equals to 25.4 times 10 to the power negative 6 meters. But this is not in standard form, okay, because this is 25.4. So we need it to be 2.54. Okay, so 25.4 converting it to 2.54 itself. Okay, 25.4 is equal to 2.54 times 10. Right? Then I continue by putting the times 10 to the power negative 6. Okay, try not to do everything concurrently together. Okay, so what I've just done is 25.4, I converted it into standard form first, maintaining the times 10 to the power negative 6 before I continue with the calculation of 2.54 times 10 times 10 to the power negative 6 will mean that this is times 10 to the power 1. Apply our indices law number 1. Okay, 1 plus negative 6, that will give us negative 5. Okay, I said your Chromebook, if you don't like it, I can pass it to the set ones, you will be very happy.
Yeah, I thought they got a new one.
Yeah, I know they are getting a new one today. Set ones are, yeah? The onboarding one. Set ones, It's the same. It's a different model. Okay, too bad. Right? So, that will be the answer for part B. Okay? Okay, now for some questions, okay, such as this one, okay, in millimeters and centimeters, usually they don't give you the conversion because it is expected that we already know. Okay, in fact, it isn't difficult because we know the conversion from millimeters to centimeters already. 1 centimeter is how many millimeters? 10. Okay, so for this one, we just have to take 2340 times 10 or divide by 10. Times 10, divide by 10. Okay. Okay, sorry. Okay. So this is just a simple conversion. Right? We do 2 more before we go into our one for the day. I'll do practice now 18 first. Yeah. Oh, sorry, thank you for reminding me. Express in standard form, so 2.34 times 10 to the power of. Does that how what? 1. megabytes. Each photo is 640 kilobytes. They gave the conversion from megabytes to bytes as well as from kilobytes to bytes. Okay, question asks how many photographs can the memory card store? What will you do, Jacob? I already read it to the whole class.
I put the new power. Oh, shoot. King Monkey got talent.
Robert, each photo is 640 kilobytes. Yes. Convert it into bytes first. Okay, so how would I convert 640 kilobytes into bytes? That's about times 10 to the power 3. Okay. If you want it, you can write it in full, but I don't see it necessary. You can just leave it this way first, then. Okay, let Jihong do it.
Oh, yeah.
Okay, convert the total capacity. So 512 times 10 to the power 6. Then how do we solve the problem?
Like King Monkey got gold talent.
How? If I wish one, times 10 to the power 6. So to find the number of photographs, we take 512 times 10 to the power 6 divided by 640 times 10 to the power 3. Okay, Jihong, there's a reason why I called you. I'm sure you know why. Okay, so number of photographs will be to take the total capacity of the memory card, okay, divided by the size of each photo. That will then tell us how many photographs can be stored. We need to ensure that the units are all equal first. We cannot take just 512 divided by 640 because the units are different. Okay, so we do the conversion to ensure that the units are the same before we do the division. And we can use our calculator to do this. What will you get in the calculator? 800. Okay. Right? Okay, I'll just do one question on using calculator to make sure that all of us know how to press into the calculator. Okay? And also to check that our calculators are all functioning the same way. Not possible to do mental sum, huh? Okay, the question has certain expectation. They want it to be in standard form and also correct 3 significant figures. So I want to address how do we have 3 significant figures in standard form. So just looking at part A, will you all press into the calculator first? Okay, and tell me what is it that you get. Okay, I really want all of us to press into the calculator. Do we all get the whole number?
No.
Does anyone not get the whole number? Wait, Does anyone's calculator not show you a whole number? her calculator shows this. Your calculator shows this, right? Anyone else's calculator shows this? Okay. It could be the formatting lah. It could be the formatting or back-end formatting of the calculator. Okay. Now, if you get this, so for easy to take note, right? You see, even though using same model, the settings might be different. The E itself, okay, the E itself represents times 10 to the power of. So this is how we interpret it. Okay, so the E represents times 10. The 10 after that is the power. Okay, so that's how we understand it. Alright? Okay, and they are equal. Right? So if I were to convert this whole number, which most of you managed to get with your calculator, to convert it into standard form, it will be 5.1984 times 10 to the power of 10, because from this decimal place here, moving to where it originally is, there will be 10 places. Okay? So for the general population, all of us, we need to do the conversion to standard form ourselves. Okay? Questions? Why is it 10 places? Because we need it to be here. Okay, and the original one is here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 9. Okay, just now this is what 10 of 9 is.
Who said that?
Okay, reset first. Sorry, Oh, times 10 power 9. Sorry, hang on, Okay. We see yours should have been right. Sorry, my bad. You reset. Okay, great. And as I said, okay, some of your calculators have this fancy button at the bottom row. Okay, that says times 10 to the power x. This one. Okay, you can use this as a shortcut to press your times 10 to the power of. So for example, if you want to do 4.56 times 10 to the power 4, to key into your calculator, you press your 4, you press your decimal place, you press your 5, you press your 6. You don't have to press times 10, okay? You just have to press this button, okay? And then a 4. Right? You can try it. It will give you the value 45600. Okay? So that is a shortcut lah. But I don't really use that button. I'll just press times 10 times that 1 0 then to the power of. Okay? So just let you know about this button in your calculator. Questions? Okay? I have not yet corrected this answer to 3SF. So with 5.1984 times 10 to the power of 9, to convert it into 3SF, it is this number over here that we're trying to change it into 3SF. So it should be 5.20 times 10 to the power of 9, okay, in 3SF. Okay, we're just converting this. The times 10 to the power of something doesn't affect. Okay, doesn't get to 3SF. Okay, questions? Alright, if you're good, take out your Chromebook. Yes. Okay, I just want us to check our calculator models. Okay, according to O-level expectation, the approved calculator list is like that. Okay, so you may want to do a quick check that the calculator that you're holding on to is actually approved. Okay. If your calculator model doesn't meet this, that means that you will need to go and get a new one now. Okay. The time period is the approved period. Don't have to quite care about it. It's the current acceptable. Usually, once it's approved, you should be able to continue. Anyway, if you go JC, you will use graphics calculator. It's a more expensive calculator, about 5 times more expensive than what you currently have. It's a mini calculator. Okay? Yes. Okay. Now, first thing is, how do we type our answer? Because we're doing it standard power of negative 9. Between the times, there must be space. Okay? The power of, we will use this symbol to represent. So I want you to type this thing into the answer space to familiarize yourself, okay, with the keys. Okay? Times, yes, is x. Okay? The times is x. One more person. Okay. Okay, so all of us are familiar with it. Okay, who's getting it wrong? There must be space between the multiplication sign. Okay? So don't worry, no points. Just make sure that it's all small letter x. I don't think it's case sensitive. Yeah. Okay? So I use the small letter x. Alright? We go with that. Okay, so let's start. Okay? Make sure that your answer is in standard form and rounded to 3 significant figures. Remember 3SF.
Still got 4 more people.
Okay. 1.60 finally, let's double the number from earlier on. 1.60 times 10 to the power of 5. Okay. 3SF, you should have gotten 1.596. Okay. 3SF will be 1.60. Right? Next. Okay, so root 3 still remaining the need. I'm going to take a look. I'll give you any more questions. Finally, everyone is getting it.
Hey, who got it wrong, huh?
1.56
Who got it wrong? Maybe after school.
Yes. Yes. Okay, don't worry, it's not going to be you.
Answer so much.
Okay, seventh question. Happy Thursday, happy question. Because of the sharp model, I think there are digits that are lost. Okay, so you will find that you get 0.000 all the way, and then last digit is 6. So that's why I accepted this as an answer. But for most of us, okay, it should be 6.57 times 10 to the power negative 9. You should have seen the last 3 digits to be 657. Okay.